Hey there, and welcome to this explainer. Look, if you're in the 8th grade right now, I really want you to lean in and listen closely, because we're about to decode something incredibly powerful. You know, a lot of times, math just feels like this dry classroom subject, right? Just a bunch of random numbers on a chalkboard that you got to memorize for some test. But what if I told you that math is actually the secret, invisible blueprint of the real world? It's literally the hidden architecture holding up everything around you, from the cash in your pocket to the way a forest grows. And today, we're going to learn exactly how to read that blueprint.
Seriously, think about this. What in the world do your weekly allowance, a dividing virus, and the seating arrangement in a massive sports stadium all have in common? I mean, at first glance, absolutely nothing, right? One's money, one's biology, and one's architecture. But underneath the surface, they are all governed by the exact same mathematical rules. They all follow these specific, completely predictable patterns of growth. And honestly, if you can understand these patterns, you can quite literally predict the future.
So the crucial point is that understanding mathematical growth is the absolute key to careful planning and making wise life decisions. As the book of Proverbs points out, abundance doesn't just, magically happen by accident. It happens through diligent planning. And you can't really plan effectively if you don't understand how things grow, or even how things decrease over time. Connecting this classroom math to real-world thinking, that's exactly what prepares you to make smart, informed choices in your own life.
Section 1. The Hidden Math Blueprint.
Okay, let's dive into this. To make those smart choices, we really need to understand sequences. They're the invisible architecture we use literally every day in business, in science, in technology. Once you crack this code, you've got that predictive power. Now, there are two primary mathematical codes we use to do this. On one side, we have arithmetic sequences. Think of these guys as the steady builders. They operate purely through addition or subtraction. On the flip side, we have geometric sequences. These are the accelerators. They operate through multiplication or division. So one builds a staircase, just steady step by step. The other, it builds a rocket ship that takes off faster and faster.
Section 2. Arithmetic. Steady step by step.
So arithmetic sequences are absolutely perfect for modeling things that grow by a fixed amount every single time. It's like adding rows of bricks to a wall, or setting up chairs in a huge auditorium, or, steadily growing a weekly allowance. Imagine you earn $5 the first week. The next week, you earn another 5, so now you're up to 10. The third week, another 5 brings you to 15. You see it? It's a perfectly predictable linear stair-step. Because the allowance increases by $5 each week, meaning we are just adding 5, this is a classic arithmetic sequence.
And here is where you get a literal superpower. You don't have to manually count out week by week by week just to figure out what you'll have a year from now. No way! You can use this arithmetic formula to calculate exactly what your allowance total will be at any point in the future. See that AN? That stands for the specific week you want to find. The first 5 is just what you started with, and the second 5 is your steady builder, the amount you're adding each week. You literally just plug in the week number for N, and boom, you've predicted the future.
Section 3. Geometric. Multiplying the magic. Now, what's really interesting about this slide is what happens when things don't just step up evenly. What happens when they completely explode in growth? Well, in a geometric sequence, numbers don't add, they multiply. And multiplication has a magic all its own. Let's say you have $1,000 in savings. Imagine if instead of just adding a flat $5 a month to it, you put it in an account that earns a 10% interest rate every single month. Because you're earning a percentage of the total, the actual amount you gain gets bigger every single month. Your money is multiplying.
This right here is the compound interest formula in action. You see that 1.10 inside the parentheses? That acts as the engine multiplying your money. It represents your original 100% plus that 10% growth. And because that engine is being raised to a power, an exponent, your money isn't just walking up the stairs anymore. It's curving sharply upward.
Let's look at a biological application of this accelerator code. Imagine a virus spreading. It starts with just 2 cases, but the nature of this virus means it triples every single day. Just look at the numbers. Day 1, it's 2. Day 2, it's 6. Day 3, it's 18. By day 4, it's already 54. The mathematical formula for this massive speed is AN equals 2 times 3 to the power of n minus 1. The number 3 is our multiplier here. It shows us exactly why geometric growth is so incredibly fast, and honestly, why understanding it is absolutely critical for scientists trying to keep us all safe.
Section 4. Real-world sequence solvers. Let's move to and see how this builds.
Okay, I'm going to put you through a rapid-fire challenge right now to test your new code-breaking abilities. Ready? Here are your first two scenarios. Scenario 1, a concert hall has 50 seats in the first row, and they physically add 10 more seats to each row right behind it. Scenario 2, you're baking, and you need to scale up a recipe by multiplying every single ingredient by 2 for each new batch. Think about it for a second. Which one is adding, and which one is multiplying?
Well, if you guessed that the concert hall is arithmetic, you totally nailed it. Because the builder is physically adding 10 seats per row, it's a steady arithmetic progression. The recipe, on the other hand, explicitly tells us we're multiplying the ingredients, and multiplication means it's geometric. You're scaling things up exponentially.
Let's throw the next set of scenarios at you. First, you save $100 the first month, and you vow to add exactly $25 more to your piggy bank every single month. Second scenario, you create this wildly popular phone app. It gets 500 downloads on the very first day, and then the daily download count doubles every day after that. So which one is the steady saver, and which is the exploding app?
Exactly. Adding a flat $25 every single month is the absolute definition of an arithmetic sequence. It's a fantastic, steady way to build wealth. But the app? The app is geometric. The word doubles is your massive clue right there. Doubling literally means multiplying by 2. If you were to write the formula for that app, your multiplier would be 2, and that little exponent would skyrocket those 500 downloads into the millions in no time at all.
Okay, here is your final, trickiest challenge. Imagine a swimming pool left out in the hot sun. It evaporates, losing 10% of its water every single day. Look really closely at the wording here. Is this sequence representing mathematical growth or mathematical decay?
The answer is decay. Because the pool is constantly losing water, it's shrinking by a percentage of its total every day, it represents mathematical decay. It's still a geometric sequence, sure, because we're dealing with a percentage multiplier, but instead of accelerating upwards, the total amount of water is accelerating downwards. It's decreasing.
Section 5. Wisdom, Morality, and Education.
So math gives us this incredible power to model and predict the future, right? Whether we're figuring out our finances, tracing a virus, or tracking a business. But deciding what to do with that future, well, that requires wisdom. And this brings us to a crucial philosophy from the Academy Godly Learners series. What is the actual purpose of being highly educated and mathematically smart if you just use that intelligence to make bad choices? Education without morality ultimately hurts us. You could be the smartest person in the room, calculating exponential growth perfectly. But if you don't have a solid moral foundation to guide your decisions, you'll just end up applying those skills in ways that cause pain to yourself or to others. Good choices fundamentally matter.
And that leads us to our final thought. True peace of mind isn't found just in a perfectly balanced bank account or some flawlessly calculated formula. As Romans points out, peace of mind is promised to those who keep a spiritual, morally grounded mindset. When you combine the diligent planning of a mathematically educated mind with a strong moral compass, you don't just find success, you find true peace. So the next time you calculate a risk or plan your growth, ask yourself this: are your numbers multiplying purely for profit, or are they multiplying for a greater purpose? Keep learning, keep planning wisely, and I'll catch you in the next explainer.